you're trying to find rotational symmetry or determine whether or not a figure has rotational symmetry, we need to remember what it means to rotate in a full circle. So if you rotate in a full circle, you're going to turn 360 degrees. That would mean that if you turned anything around, you would eventually get back to its original shape. And so that's why rotational symmetry is only measured up to 180. If you have flipped your shape completely around and you have not seen it match itself, the original image, it's not going to have rotational symmetry. So, some tips for finding it are to first really just look at your object. If it appears to be symmetrical, how many similar points or sides does it have? And then you're going to put this number into 360. You should check for symmetry at the resulting number. Don't always assume it will work. So in this particular one, there are 16 points. 1, 2, 3, 4, 5, 6, 7, 8. So you can see that it will be 16. We do 360 divided by 16, and you get 22.5. That means that every 22.5 degrees, and anything that 22.5 goes into, you will get the same figure back. So from here to this tip is 22.5 degrees. And until you go another 22.5 degrees, it won't look the same. So you're going to try it. We have the same sunburst, but now we have these little dots inside. You are going to pretend that they are perfectly symmetrical and in the exact same spot in each of the points. Try and see, make a guess, and see what kind of rotational symmetry you think that this has. In 5 seconds, the answer will reveal itself. There are actually 8 similar points. I would not use the 16. And here they are. 1, 2, 3, 4, 5, 6, 7, 8. So instead of saying 16, I would say 8 points are the same. I would do 360 divided by 8, resulting in 45 degrees. And I would say it has rotational symmetry every 45. And we can see why you don't want to really use 16. This figure below has been rotated as if we pretended it had 16 points. So we said we have 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 16 all the way around. And we did 360 divided by 16. If we only shift this one right here, 22.5 degrees, it's going to go right here. And take a look now and determine whether or not these two figures are identical. Concentrate here and here. And so you can see if you only go 22.5 degrees, you screw up where the points are. With this version, using that you had 8 points and you said you have to rotate it 45 degrees, this is what results. You can see that this figure here is identical to our original. So you're looking for not exactly how many points it has or sides, but how many of them are similar to each other. So let's try some of these here below. If you have this little sunburst, let's pretend that this and this and the two sides, east and west, let's pretend that these parts of the sun are all colored in. Let's look at how many are exactly the same. So instead of saying that we have 8 points, I would say we have 1, 2, 3, 4 that are identical. And I would do 360 divided by 4, and I would get that every 90 degrees is where we're going to have rotational symmetry. So take a look at the second one and make a guess as to what you think it has, what kind of rotational symmetry it has. If you said that it has 2 points that are similar, and so it's 180 degrees, you're completely correct. In fact, if we select this object and then we ask it to format and to rotate it 180 degrees, we're going to get the exact same thing. So if we ask it to rotate it 180 degrees, which I've got right here, I'm going to hit OK. And let's see, it looks exactly the same. And it's because it had two of those similar points. Now, hit pause, take a moment, and count how many points does this particular little starburst have. Start, if you have to, mark 1, 2, check it out, and in 5 seconds, this is going to reveal the answer. If you got every 15 degrees, you were totally right. And even though this crazy thing has 24 points, if you only colored this very top one and this one at the very bottom, this would only have rotational symmetry at 180 degrees because it has two that are similar. So you want to take that into account. What is happening in the picture? So you're going to want to try these 6 problems and bring these to class. At the very end of the video, I will put up what the answers are. And I'll warn you so you can hit pause and make sure you try them on your own. But let's come down here for a second. We're going to recall line and reflectional symmetry. That's when all points on either side of the line mirror each other. So we're going to take this highlighter and we're going to sketch in all the lines of reflection. So normally that would be one. You could fold it that way. We're going to have to change pens for a second. This would also be a way to fold it. You can also fold a paper that's perfectly square right down the middle, or this way. These will all work. So we would have 1, this is still line 1, 2, 3, 4 lines of reflection, or 4 lines of symmetry. So I want you to draw in all the folds that are possible. Remember, when it's a long shape like this, it's very similar to when you have a rectangle. And put in all the lines of reflection or lines of symmetry that you can on the next few shapes. And then using what you know about rotational symmetry, I want you to try and find 4 letters that have rotational symmetry. After you find your 4 letters, check out if any of them have no line symmetry. And if they all can be divided up with a line, see if you can think of any letters of the alphabet that only have rotational symmetry. As you can see, Microsoft Word is not responding. It is having a meltdown, so I will not be posting these answers for the top 6. Bring them to class and we'll see if you got them right.